This is video number 2 for sections 2.1 and 2.2 using linear models. This is really just a continuation of the last problem, the smoking problem. Letter G says, let's use the graph of our linear model. Now that's just a reference to that gray line that we drew at the end of the last part. That gray line, this line, is our linear model. And part G says, let's go ahead and use that to estimate when 30% of Americans smoked. Well, let's see, 30%, that's a P. It's a percentage. So what I need to do is I need to find 30% on my P-axis. I think that would be right here. And I need to go over to my linear model. And then from there down to the T-axis. And I don't know exactly what that is. Maybe it looks somewhere around 13. Remember, this was 10 and this was 20. I think we've hit it around 13. We're saying that on our linear model, the point 13, 30 is a point on the graph. Well, that 13 is a T. What's T again? T stands for the number of years since 1970. So that means 13 years since 1970. In other words, 1983. That's the answer to part G. Our estimate is that 30% of Americans smoked in the year 1983. Now, question H. Is this an example of interpolation or extrapolation? Interpolation means asking and answering a question within the range of data originally given. Extrapolation means asking and answering a question outside of the range of data that was originally given. Now, our question in part G had to do with the number 30%. If we go back to our data, here's our percentages. They're between 19 and 37. 30 is within those numbers, between 19 and 37. And so what we say is that this question was an example of interpolation. Let's go down now to letter I. Letter I says, go back to the gray line, go back to the linear model, and estimate what percentage of Americans do we think will smoke in the year 2020. Now the first thing I'm going to have to do, of course I can't find the year 2020 on my graph, I have to convert that to a T. T means number of years since 1970. Well, if you subtract 2020 minus 1970, you get T equals 50. So the T that we're talking about is T equals 50. When I go back to my graph, I can look up T equals 50, 10, 20, 30, 40, 50. I can go up to my model. It just barely hits there on the edge. I can then go across to the P-axis. And again, I know my picture isn't perfect, but it looks like I'm hitting the P-axis around 10. In other words, the point 50, 10 is on my linear model. What's the 10? Well, it's 10%. That then is the answer to question I. Our estimate for the year 2020 is that 10% of Americans will smoke, according to our linear model. Letter J, was this an example of interpolation or extrapolation? Well, the original question was about the year 2020. In other words, T equals 50. If I look back at my data, my years only went 0 to 40. 50 is outside of that section of data. Therefore, we call this an example of extrapolation. Let's go on to letter K. Estimate the P-intercept of your linear model as an ordered pair. Well, we'll go back up to our gray line. P-intercept simply means the spot where the gray line hits the P-axis. Well, I can see exactly where that happens. In fact, I don't even have to estimate it. Because we chose that first point as one of our points to connect the dots, I know exactly what point that is. That was 0,37.4 from our original table. So going back down to part K, we're saying that the p-intercept of our linear model is the point 0,37.4. It might have been something different if we had picked another couple of points. All right, part L. Let's go ahead and give a real-life meaning to this ordered pair. Of course, the whole key here is understanding that in this problem, the first coordinate is always a t, and the second coordinate is always a p. T stands for number of years since 1970. Well, if a t is 0, that means we're talking about the year 1970 itself. This is telling us something about 1970. In 1970, what? Well, 37.4, that's a p. That's a percentage. In 1970, 37.4% of Americans smoked. Letter M says, go back to the graphing calculator and adjust your window so that you can see all the way out to the future year 2070. So let's go ahead and do that. So here's our previous picture. Remember, we had counted by tens, so on the t-axis here, this was 10, 20, 30, 40, 50. T means number of years since 1970, so I believe that's taking us out to the year 2020. If I want to see more, I just need to go to the window and think about which number to change. Now, I want to see a further year. Years in this problem are the t's, which for us are on the x-axis. I don't need to go any earlier in time, so I'm not going to change that number. I need to go further out in time. That would be the x maximum or the t maximum. Right now it only goes out 50 years. If I want to go to the year 2070, that's 100 years from 1970. So I better change this to 100. Everything else I think will be fine. Then I'll choose graph. And you'll notice the picture is now adjusted. The dots are a little bit more squished together. I didn't change the fact that I was counting by tens. So I've got 10, 20, 30, 40, 50, but now all the way out to 100, which would be the year 2070. Why don't you take a moment and copy this picture onto your paper quickly. So hopefully your picture ends up looking something like this. I've got my t-axis, my p-axis. Now I'm counting by tens all the way down to 100. I'm still counting by tens up to 50 on the p-axis. My red dots are a little bit more squished together than before, but this is the same information we had earlier. Now go ahead, just like we did earlier, and connect the first and fourth dots to put back in your linear model. When you do that, you should end up with something like this. That gray line is that same linear model we had used before. Part N on our handout goes on to ask, now that we've got this bigger picture, estimate the T-intercept of the linear model, again as an ordered pair. Well, T-intercept means the spot where that gray line crosses the t-axis, and I can see it appears to be right around here. Now mine happened to hit, it looks like right at 70. Of course, again, we're not drawing our picture perfectly, so it looks like we're saying that our t-intercept is taking place at the point 70, 0. Well, let's go on to part O. What's the real-life meaning of that ordered pair, 70, 0? Again, the key always is remembering that the 70 is a T, years since 1970, and the 0 is a P, percentage of Americans who smoke. So, 70 years since 1970. You might have to think for a minute about what year we're talking about there. That would be the year 2040, 70 years from 1970. In the year 2040, what are we saying? Well, we're saying 0% of Americans will smoke. Or maybe even better, we could have said no Americans will smoke. If you look at question P, question B says, we might not want to believe this answer. This is definitely an example of extrapolation. We're going way out into the future here. In fact, we might even suspect that this is an example of what's called model breakdown, that perhaps the model is just giving us bad information. Question P says, why might we think that? And of course, the simple answer is, even though it does seem like fewer Americans have been smoking over the last several years, we would have to wonder if we'll reach a point where no one will smoke. It's unlikely, we can say, that no one will smoke. You have to remember that the model is just a model. It's not going to describe every situation perfectly. The closer you are to the data, the more you would trust it. The further out into the future you go, perhaps the less likely you would trust it. Finally, letter Q says, let's talk about the year 2030. And let's suppose that when that year rolls around, it turns out that 16% of Americans smoke. The question says, what is the error between that actual value and the prediction given by our linear model? Well, we're going to have to go back up to our linear model. We're going to have to think about what t number we're talking about. 2030 minus 1970 is 60. That would be a t-value of 60, which is right here. And so once again, I start at 60. I go up to my linear model, I go across from there as best I can to my p-axis, and I don't know exactly where that is. It looks to me to be somewhere close to 6, say, and that would mean 6%. So our model predicts 6% for the year 2030. The actual value we're assuming turns out to be 16%. To find the error between the two just means to subtract. So we would say 16 minus 6 gives us 10%. The error between the actual and the prediction would be 10%. Once again, the model isn't perfect. It simply gives us the best prediction it can based on the current information.